All right, so we've talked about angular linear velocity, angles in standard position, coterminal angles. Now we're going to move into what's called a reference triangle and reference angles and how we're going to use those to actually solve problems. The first thing I need to do is show you how to actually draw a reference triangle. Now it's going to be based off of an angle in standard position. So I have an angle in standard position here, and let's call that's my rotation. Let's do a different one over here. And let's say here is my angle in standard position. To draw a reference triangle, we're going to pick a point on the terminal side of my angle in standard position. So right here. And we're going to take it, make it perpendicular. We're going to drop a line down that's perpendicular to the x-axis. We'll say that again. It needs to be perpendicular to the x-axis. So here, I drop it down, it's perpendicular, and I make a right triangle. This is a reference triangle. This angle right here at your origin, that is your reference angle. Now we'll get more into reference angles later on. Just know that this angle right in there, we're going to call it a reference angle. Now for this one, I want to pick a point on the terminal side of the ray. I want to draw a line perpendicular to the x-axis. And here is my angle, and there is my reference triangle. So this is whenever we're going in to solve problems, we're going to get into triangles. So we have our angle, we're going to make them into 90-degree triangles by drawing a reference triangle. So let's look and see how I can ask you a type of question off of this to try to figure different things out. All right, so here I have an angle drawn in standard position. We want to say it's right here. And I actually don't know the angle, but I'm going to tell you to find x. It does tell me in the information that OP, if you remember from geometry, capital O, capital P, that's going to be a line segment without having the segment above it denotes distance. So the distance of segment OP is 6. So we know from OP, this distance is 6 right here. But I need to know what x is. Well, what we're going to do is we're going to draw a reference triangle. We're going to take a line and make it perpendicular to the x-axis, making a right triangle. I'm going to use this point and look and say, you know what? This is my x. My y is -5. I know my x has to be negative because I'm in quadrant 3 because I move left on my x-axis. So I know x has got to be a negative. So I want to put that there just to remind myself that, hey, that x has got to be negative, or if you give me the positive number, you'll be wrong because you will not be in quadrant 3. So from here, we just use our good old friend Pythagorean Theorem. I know that my negative x is going to equal, let's just say x equals the square root of 6 squared minus a -5 squared. We do the math. We have the square root of 36 minus 25, which is the square root of 11. Therefore, I know that negative x is going to be negative square root 11. Therefore, this answer right here is negative square root 11. Negative square root 11 is the value of x at point P. So, drawing your reference triangles using the Pythagorean Theorem, pretty straightforward to find that point. So, let's look at one more example. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.